This is video number 1 for sections 3.3 and 3.4. Modeling problems, slope and y-intercept are given. This lesson is all about application problems dealing with linear systems of equations. There isn't really any new algebra in this lesson. We're going to use the algebra that we've been learning in order to work some application problems. There are two types of application problems that we're going to see. The first type is modeling problems. In other words, we're going to be dealing with problems similar to what we worked so hard on in Chapter 2. Okay, well, let's take a look at this first example we've got here. Go ahead and read through the example. This problem is about spending money for ads in two different places, either on the internet or in the newspaper. And we've got some information here. It says that for the internet, back in 2007, the total dollars spent on ads was 21 million. That's been going up, it says, by about 2 million per year. On the other hand, for newspapers, it looks like 42 million was spent in 2007, but that's been going down by about 6 million per year. And of course, this shouldn't be shocking to you. Obviously, more and more people are turning to the internet for their information. The first thing we need to do if we're going to do modeling is write equations to represent what's going on here. And in order to do that, we need to make sure we're clear on our let statements. This time they have not been provided for us, so we need to go ahead and fill in the information. Let's do it in the easiest way we can. So we'll use I of t for the internet spending. I of t is the money spent on internet ads. We want to say in millions, because we don't want to have all those zeros extra. And let's see, we also need to pick a starting year. T years since, well, we want to make our lives as easy as possible, so I should just pick the year that they mentioned, namely 2007. Similarly, for the N of t situation, N will be the newspaper money, once again in millions, and we'll pick that same starting year, that 2007. Okay. Now we want to go ahead and write an equation for each situation, which will make it a system, right? A system just means two equations in the same problem. The hint says this should be really easy, and this really goes back to the title here. If you are handed the slope and y-intercept, of course it's super easy to write the equations down. Now when you're going through the homework, there's going to be all sorts of different things happening to you. Sometimes they'll just give you the equations. Great. Other times they'll give you the slope and y-intercept. They may give you 2 points for each equation. They may have you do a scattergram for each equation, right? We've done all that before. Just follow what they want you to do. In this case, let's see, we'll do each equation one at a time here. So let's start with the internet equation. The reason that it's so easy is since we picked 2007 as our starting point, I know the y-intercept. 2007 becomes our 0 year, and so I know that 0, 21, right, 21 million was the start, is my y-intercept. What about the slope? Well, that's this per thing, right? It's been going up by $2 million per year. So my slope then is 2. It's handed right to me. Therefore, the equation, let's go ahead and use the right letters, would be I of t equals 2t plus 21. Y equals mx plus b. Very similarly for the newspaper situation, I know the y-intercept because 2007 is my 0 year, so I know the point 042 is on that equation. And let's see, what about the slope? The newspaper money has been decreasing by $6 million per year. There's the per. We know the 6 is the slope. Just be careful here, though, since it's decreasing, I would have to say the slope is -6, and so that means my N of t equation is -6t plus 42. Okay, I now have an equation for each situation. Taken together, then, this forms a system of equations. Let's take a look at part C now. This is where the Chapter 3 stuff now comes into play. Part C basically says, let's figure out now what year it was where the internet money and the newspaper money were the same. I put that in all caps because same is really the word to be looking for in these problems that alerts you, oh, they want me to solve the system. They want me to find that special X and Y, so to speak, or T and money information where these two things are the same. Well, that's solving a system of equations. We also, it says, want to know how much money that was. So I want to know two things. I want to know when it happened and how much money it was. I know it's going to happen at some point, right? Because in 2007, the internet money was low, but it's been going up. The newspaper money was high, but it's been going down. At some point, those two amounts are going to be the same. Well, it says we want to use algebra to do this. We have two algebra methods to choose from, right? We have the method of elimination and we have the method of substitution. There's also a hint given here. It says don't use the function notation when you're trying to do this. That's very important. It gets very confusing. You should replace the I of t and the n of t with y's, which is always allowed. Let's go ahead and do that. Now, as far as which method to choose, you certainly have your choice. Whichever one seems easier to you is great. The one that pops out to me is the method of substitution because I already have a variable by itself. I can just easily substitute here. This y is by itself, so I can take that expression for y and substitute it right into the other equation. Let's write that down. And now we have an equation that we can easily solve for t. Looks like I need to add 6t to both sides, maybe subtract 21, and then divide both sides by 8, and I'm all set. This is a real life problem, so I think we should go ahead and divide that. And I got from the calculator t equals 2.625. I'm sure we'll do some rounding of that later, but I don't want to round it yet because I'm not done using this number and I don't want to introduce errors into my work. So even if it had come out, 7 or 8 decimal places, I would have kept it at least 3 or 4 places until I'm done using it. Well, the last step to solving the system, we have the t, we just need to figure out the y, so I'm going to have to take this and go back up to one of my original equations here and fill in that t value and then figure out the y. I can just use the one I circled here, so let's do that. And then grab the calculator. Okay, that's the end of the algebra. Now, though, I need to think about how to give my answers. I'm not going to give an ordered pair because this is a real-life problem. I'm supposed to answer a couple of questions here. So let's go back. What did we want to know? Let's see. The first thing we wanted to know is what year the spending was the same for both. Well, I just have to think for a minute about which of my numbers has to do with years. And of course, that's the T. Remember, T stood for number of years since 2007. Well, we haven't been doing months typically, right? We've been rounding these values to the nearest whole number. 2.6 rounds to 3. A t value of 3 would correspond with the year 2010, 3 years after 2007. So that's one of my answers. And then the other thing says, well, how much was spent? Well, the money, that was the y values in these problems, right? Remember, in millions of dollars. So I can go to my y value. Let's pay attention to the rounding. It says round to 1 decimal place. So that makes this 26.3. And so what we're saying here is in 2010, the spending for both internet and newspaper was somewhere around $26.3 million. Don't forget the million. That's important. Okay, the last thing we want to do is see if we can check this quickly using the graphing method on the calculator. So let's move over to the calculator. Okay, so for the graphing method, I need to go to the y equals area. I need to make sure my plot is turned off. It is, because we're not doing a scattergram here. And I need to type in my two equations. Remember, you have to use x instead of t, so let's go ahead and put those in. All right, I've got the equations in. Remember to use the negative button down here and not the subtract button for the -6. And then I guess I'll have to do a little bit of thinking about the window that I want to use. X in this problem, that's our t's, our years. Certainly there's no reason to go negative years, so I think I can start that at 0. Now we already know that the answer came out to be around 3 years into the future. Why don't I just go 10 years? If I truly didn't know, I'd be, making just somewhat of a guess here. I could always adjust it if I needed to. Counting by 1 seems reasonable. And then the y's, that's the money. Again, no negatives, so starting at 0 seems like a good idea. And then as far as a maximum, well, again, we've already solved it. I think it came out to be somewhere around 26. But if I want to see everything, I mean, remember there was that one number, 42 million, so I'm thinking I better go up at least to 50. You just use the information in the problem to help you think this through. Maybe I'll count by tens here. And then I'll hit graph, and I ought to see a fairly decent picture. I know the blue one is the internet spending, that's the one that's going up, and the red one is the newspaper spending, the one that's going down. Of course, I'm interested in finding this spot right here, the spot where the two spending amounts were the same. And on the calculator, you have that intersect feature, right? So you go to the Calc menu here, hitting the second button, and then Calc, and then choice 5, Intersect. And you're being asked those questions. Do you want to use the first curve? I'm going to say yes by hitting enter. Second curve, yes. Guess means move kind of over close nearby the intersection point. And once you get close by, hit enter one last time. You know you're done when it says intersection. And sure enough, there's our values we had before, the 2.625 and the 26.25. So a nice way to check our work. Let's see, all we're supposed to write down here is the window we used. We used 0 to 10 on the x-axis, and we used 0 to 50 on the y-axis, and that gave us a pretty good view. Again, don't lose the point here. If you have two different equations in an application problem and you're being asked when they are the same, that is a tip-off to solve the system of equations.